Okay, from last night, let's start off like with the usual. Let's go over any questions that you might have. Again, remember, as I try to emphasize to you, make sure you're attempting that homework. If you got a question, let's go over it. And then today we're going to add on the other last piece of special rights. There's only two out there, the 30, 60, and the 45s. Grace, start it off. Number 8. It's on this side? Yes. Okay. So with number 8, the nice ones are when, again, the side links, the two legs, are the integers. Okay? 5, 5, 5, or 2 kind of rolls off the tongue. 6, 6, 2. Now, on this one, the side link, or the leg, I should say, side link, the leg is not an integer. It is a little bit crappier in that regard. It is, the other leg is the same length, it's congruent. So that's not the issue. It's getting that hypotenuse. So again, we use our reference triangle. I will have that on there until Friday. Friday morning, I will erase that preparation for a mini quiz on Friday. It's going to be non-calculator. So this is with the SAT again, how that has that phrase out. And as I was working through it yesterday with my other groups, I realized part of the reason why they use the S's, not necessarily the as like L for leg. Again, this is coming from a square. And in a square, you know the size of the square, we use typically S for the size of the square. But in a square, when we cut that in half, as we saw first semester, we get 2 45s. So that's probably where they're using the S's from, the side for a square. Long story short, we take the leg times root 2. So as we go back to number 8 then, taking it 9 root 2 over 2, taking it times root 2, it's really more or less just a fraction problem. 9 root 2, why that just is ugly. Let's try this again. 9 root 2 over 2, take that times what our pattern said yesterday. So we take that leg times root 2. So let's go back to again about, I don't know, 4th grade or so, 3rd grade, where we started learning about multiplying fractions. Multiply numerators, just like we did kind of with division of fractions over the last few weeks, multiply across. Root 2 times root 2 gives me a 9 square root of 4. Denominators, 2 times 1. And there, right there, we get ourselves a perfect square, right? And the square root of 4 gives me 2. And 9 times 2 gives me 18. And 18 divided by 2 gives me that's where I'm getting that 9 from. Okay. Again, calculators are kind of almost still useless here. If the numbers get pretty large, that's where it's okay, obviously, to use that calculator. But again, they are kind of useless as we work through here. Okay. All right, keep going. Yeah, Adeline.
Number 14 is the next one on the back.
Sure. Let's take a look at number 14 there. Now, number 14 on the back here, I always like to kind of intermix old stuff here. And as I look at number 13 and 14 on the back there, first thing I notice about those is it's not side links on those. Those are angles, right? So it has nothing to do with 45s or even Pythagorean theorem here. These are angles, right, Adeline? How many degrees inside a triangle?
180.
So what we're going to do is just take these 3 angles and add up to 180 degrees. So there's my equation. So just like with, again, we were preparing you guys as best as we can for the SAT. I'm intermixing old stuff as we go throughout this school year. I'm just adding up those 3 angles to 180 degrees and solve out for x then. Okay? Just combine like terms and solve out for x. Should get x to be hopefully 6 in that regard. You have a brain part?
We got 6.25, so just trying to figure out where I would put.
So combine those like terms. So we get the 90 plus the 1 plus the 65 plus.
The way I did it, like the way I set it up is I just subtract 65 and 90 and 180 and just set it up as 4x plus 1 equals 25.
Yeah, and that's, yeah, right here. And that's nice because it is a right angle off that. So as we do that there, as we are doing off that, 180 minus 90 minus, what is it you said, 65, and minus a 1, and 24, right? And divided by a 4. And that is a 6. So maybe you just typed in a calculator wrong or something.
I think that's what it is.
Weird.
I have
Yeah, and if he did number 13 right, then you should be fine too. So, yeah. All right, keep going. Anything else off of there? Okay. Um, as always, make sure your name's on it. Throw in the basket. And today we're going to do one more round, but it's a 30-60. Get out your notes. What you got? I'm missing one. Just make sure your name's on it. Okay, Tucker. And I'll get to it as soon as I can. All right, bud. All right. Again, get your notes out. Anybody absent yesterday? Over here. Okay. Get your notes out, guys. And let's pick it up on the other special right triangle today. There's only two of those out there. It's the 45s and the 30-60s. And as I told you, with those two, we are going to use those obviously in geometry all throughout from this point on throughout this school year. And then as you roll into Algebra 2, you're going to learn about in Algebra 2 a different coordinate grid. You've got the XY axis, and then you'll learn about a different type of coordinate grid we call the polar coordinate grid. And then they really go much further with special right triangles in that regard. And then to pre-calculus and calculus for sure. And then also my sophomores, as you take, if you sign up for physics next year, I know I got a few sophomores. Eric, are you taking physics next year? You'll use that quite a bit in there. If you're taking, again, like architecture, construction, drafting, that type of stuff, those also roll into those types of areas as well. All right, let's start off like we did yesterday. I'm not going to worry about the warm-up for today. Let's get right into 30-60s, okay? But like we did yesterday with things, I got set up to kind of try to discover a little bit of the pattern that's happening with a 30-60. Give you a minute here. Let's use the Pythagorean theorem real quick. I give you two sides, which is not going to usually happen here with the 30-60, but I give you two sides. I like to go through and use the Pythagorean theorem and answer up the same questions that we did yesterday on things. Go find me x, the side length, and go find me that y, and do your best to classify that triangle for me. You can classify it two different ways. All right, it's a right triangle for sure. That's one way. What can you say about the sides? How can you classify by the sides? So I'm gonna give you a minute here. Find me the x and find me the y. I'll give you a minute there as I take my attendance real quick and answer up all those questions there and try to find a pattern that is happening. Say with those two pictures, with those two triangles, because there is a pattern happening with that specific setup that's there. All right, Myra's absent. And Silas. Okay, so again, as you're working through here, we'll go through 3 and 4 in just a quick minute. Again, on Friday, we're going to take a mini quiz. Tomorrow, we're going to do a wrap up of everything with 30-60s and 45s, but apply that to some application problems as well. So let's wrap up with some applications of 30-60s, 45s, and then we're also going to bring in some applications of Pythagorean theorem as well. And Friday, we'll do a mini quiz, no calculator. I will erase the board, so make sure you know those two reference triangles, and you will not have those, nor will I give you the SAT formula sheet just yet. And then I'll give you a quiz review in preparation for Monday. Okay? All right, let's do this real quick. First thing is finding that missing angle. I mean, hell, we're talking about 30-60s today, so duh, there should be a 30-degree angle. Okay? And classify the triangle. Again, duh, it's a right triangle. So what else can we say about, say, the sides? It's a 30, 60. All the sides are different, and it's a, scalene. Correct. Okay, so we can copy paste that on over. And it's, again, a scalene because all three sides are different, and duh, it is a right triangle. Now, finding those two x's up there, doing Pythagorean theorem, because at the moment, that's all you know how to do. All right, finding that, what did somebody get for x right here in simplest radical form? What do we got? Should be getting 1 root 3. Should have done that, correct? No, you do not need to have that one. I'm putting it there to draw your attention to that pattern, hopefully in just a second. But no, I do not want that one there. It's understood that it's there. On the next one here, you better have a number there. Okay, when you did Pythagorean theorem here, what did we get on this one? Okay, so just as we did that yesterday, 45s, from that one to that one, and if I asked you, and if I had another one up there, I'm just going to throw another one up here real quick. That looks more isosceles. That's a little bit better. And let's say I throw out a 8 right here. Okay, if I throw that an 8 out, and that's got to be that. What would that missing side then be here based off of what we kind of saw those first two, generalize it out? What's that missing side going to be, you think? So obviously you are seeing a pattern that's happening on those two triangles. So let's put it together on our reference triangle down below, and that's what the SAT is going to do for you. Okay, they're going to create that same reference triangle off that. So in a 30-60, all right, the length of the, okay, as you try to figure that out, the length of the blank is twice the length of the, now, we got two different legs up there. They're not obviously the same. It's not isosceles. So we have a longer leg and we have a shorter leg. And that is going back to what we talked about through January, February. We have a longer leg, shorter leg. And that is all in reference to what angle you're across from. So again, stuff that we did back in January leads us to this point now. Smaller angle is across from the shortest leg. Medium angle, medium side, and right angle is the largest angle, so hypotenuse is the largest side. So, right there one more time, the length of the blank is twice the length of the shorter leg. What's that blank, somebody? It is the hypotenuse, okay? So if you look up above, there is a relationship happening there where I see that twice the shorter leg. That twice the shorter leg gave me the hypotenuse, right? 2 times, what was it? 2 times 1 gave me 2. 2 times 2 gave me 4. The one I created, 2 times 4 gave me 8. So that is, for sure, giving me a generalization there where, okay, here's my smallest angle. Therefore, this is my, I believe the SAT uses an X. Let me double check that. They do. Okay, they use an X. And I'm going to go ahead and label this. Now, they do not write this as the short leg. I'm just going to write that in, though. So that's our short leg because it's across from the 30 degrees. And then this is twice x. And duh, that is our hypotenuse, right? All right, so there's that relationship. Now, it's not isosceles. So the other leg, that is our longer leg, right? Because it's across from the 60 degrees, it's the longer leg. We have a short leg, a long leg, and a hypotenuse. So the length of the longer leg is root 3 times the length of the short leg. Okay? So the short leg is what we need to know. You know the short leg, you've got the other two things. We always want to know what the short leg is. If we got it, we're good. We know everything. So if we know what the short leg is, take it times root 3. And we've got the long leg. Again, the long leg is across from the 60 degrees. And the hypotenuse is always across from the right angle. All right, so there it is. That's our other special right. That's the one that's not going to say ever go away. And I'll throw that up there. We're going to refer back to it now. X, 2x, and x root 3. Now, usually what happens here, 45s on their own go fine. 30/60s on their own go fine. But then later on, once you leave me, usually what happens is students kind of combine that in their head a little bit, especially with that x root 3, that 2x, and that s root 2. That's usually what happens. They kind of crisscross in their heads. Let's not do that, but it does happen. All right, let's go right at it. First thing is, what I suggest doing is, you've only got one piece of information, right? And you've got the 90 and 60 in there. Go through the other missing angle in there. All right. The missing angle that we have is 30 degrees. And then the other thing I always suggest is label the things that you got. What does the 18 represent? The 18 represents the what? It represents the hypotenuse. And what does that hypotenuse then represent? X, x root 3, or 2x? Use your reference triangle or look above on your paper there. Yeah, it's the hypotenuse, which is 2x, right? So I would always go back to that reference triangle. The more times you go back to it, you're going to remember it and you'll be on your sheet. Okay? So I'm going to always keep walking back to this, label that up, keep going back to that. And once you realize, boom, 2x is my hypotenuse to 18, there you go. There is your little mini equation, and we all know that x equals 9. Okay, x equals 9. That's always going to give you the short leg. That's going to give you x as the short leg. Now you got to realize, hey, that's across from 30 degrees. That is the short leg across from 30. So what variable there is across from 30? Is it what? Yeah. Is it v or u? V. It is v. So as Meadow said, it's across from v. So that is, what would you say? 9. Okay? That's that whole relationship that we get spent time through January on. What are you across from? Once you have the short leg, you got the other missing one. Across from 60 is x root 3, 9 root 3. So across from 60 is 9 root 3. This one doesn't roll off the tongue as pretty. 5, 5, 5 root 2, 9, 9 root 3, 18 just doesn't roll off as pretty. Okay. All right, one down. Let's go at it. Let's look at number 6. First thing again I always see is you're going to always, excuse me, you usually have one missing. I would go throw in that other angle just again visually give you that 30, 60, 90. And then it also gives you an idea of to know, hey, that 4 root 3 is given to us. What is that 4 root 3 across from? Is that the long, is that the short, or is that the hypotenuse? And what does that 4 root 3 represent then? What's that 4 root 3 represent?
Long.
It's the long. It's across from the 60 degrees. And in my reference triangle, across from 60 degrees, that represents what? It represents x root 3, right? Get to know that reference triangle. There's your equation. Set it equal to. Now, just like we said yesterday with the 45s, this one is easy. It's the easiest I can give you because it equals a root 3. You can just say, hey, it's 4. Look at it and be done with it. X is 4. Because it has a root 3 there, and what's going to happen to those root 3s? You can just say they cancel out, and you're done. X is 4. And once you have that variable of x, you got the short leg. Which is now what? Which variable is now 4? Which variable is 4? Thank you. And therefore, we've got the y, and then the hypotenuse is 8. Okay? Now, those are kind of the easy ones we start off with. Let's see what the backside gives us. All right. Now I gave you some not as pretty ones. So let's get crazy now. All right, on the backside, let's go. Angle that I'm missing is 60, and this is ugly now. All right, What's that 2 represent? My long, my short, or the hypotenuse? It's long, so I'm going to make it equal to x root 3. Get in that habit. It's across from the 60, it's the x root 3. This is ugly because I know it's going to be x root 3 and there's no root 3 there. So let's set that equal. Now on the last one we just did on the previous page, the root 3 is canceled. That's not going to happen here. So I'm going to have to rationalize. Let's do that. We're going to divide by root 3. Now I know, again, as I said yesterday, some of you are going to be able to keep track of that in your head. Cool, more power to you. But we got to rationalize here. So that work with division that we've been doing, let's do that. All right, rationalize that denominator. Root 3 over root 3. All right, multiply across 2 root 3 over a perfect square of 9, and the square root of 9 is 3. Can we do anything else with that? No, that's ugly. It is what it is, though. 2 root 3 over 3. Now, what does that represent? Which variable up there does that represent? That is my short leg. Correct. That's always going to get you that short leg. In this case, it is y. 2 root 3 over 3. That is an ugly problem. Now, we got to double that, right? Because we want to take the short leg out to the hypotenuse. And my pattern says take that short leg. Got that now. Double it out. It's giving us the hypotenuse. So now go back to kind of like the homework question Grace asked a little bit ago from yesterday. Double that out. Okay? 2 root 3 times 3. Can you multiply fractions? Okay, back to radicals. Can you correctly multiply a 2 root 3 times 2? What's that numerator going to give you? 4 root 3 over, yep, it's ugly. The 30/60s tend to get uglier than the 45s do. Not always, but they tend to be a little bit uglier. All right. That's about as ugly as they get, but they tend to be uglier. All right, let's go to the next one. Match it up to your reference triangle. What's about the next one? What's that 9 represent? Short leg or hypotenuse? It's the hypotenuse. So when you look at your reference triangle, that hypotenuse represents what? Represents what? 2x, right? So we're going to set that equal to 2x. All right, divide by 2, right? And x equals what? All right, I'm going to be a little picky with you. Okay, so being a little picky with you, and Sam goes, why in the world do I have to do that, Mr. Josh? I'm aware of that. So, usually in math, we've talked about this randomly throughout the school year. Just the formatting issues in math, usually decimals and radicals, decimals and pi don't go hand in hand. Usually it's fractions and pi, fractions and radicals. So 9 over 2. All right, so not decimal, not 4.5. So 9 over 2. Now what does that represent? That's the short leg we just found. So what does that now just represent we found? X or Y? That's my short leg across from the 30. Filled out that triangle we're finding. Take it from the short leg out to the long leg. That's across from the 60. That's the long leg. Reference triangle says short leg times root 3. So again, short leg times root 3. So 9 over 2 times root 3. There's nothing to do with that, is there? 9 root 3 over 2. That's it. Don't give me 4.5 root 3. It's not wrong. It's just in math we usually don't use a decimal root 3. Don't use usually decimal pi. Usually it's written as fraction pi, fraction decimals, sorry, fraction radicals. Okay. Get into those good habits. Okay, number 9, next up. Another kind of ugly one here. I specifically put this one out here, that 3 root 3. What's that 3 root 3 represent? Short leg, long leg, or hypotenuse? It's my shorter leg. Just because that root 3 on there doesn't make it the long leg. It's across from the 30. So that represents just the X. It's the short leg. We're good to go. We're golden on this one. So double it out to get the hypotenuse. Always look at that 30, 60, 90 lineup. It's the short leg. Double that out. What's 2 times 3 root 3? 6 root 3. That's a quick one. All right. Now take that times root 3. 3 root 3 times root 3. Lots of 3's there. 3 square root of 9. 3 times 3, which is just 9. Okay? Why?
No, I get it.
Oh.
You just wrote a whole lot more than
Because I always show my work. Sam. You know that. All right. This. Okay. All right. Let's keep rolling along. Draw me out that picture. Number 10. Know what the pieces are. Draw me out a 30, 60, 90. All right. The shorter leg is 5 feet long. Let's go do this just like we did yesterday. Draw me out a 30, 60, 90. Go. Shorter leg is 5. I don't care how you draw out that 30, 60, 90. We just saw a bunch of different ways to draw a 30, 60, 90. You can match up to your reference triangle. I don't care. I don't care. Still don't care. Just make sure as you draw that out, though, wherever you put that 30 at, your 5 better be across from that 30. The same as mine. Who cares? I don't. Now, as we said here, it's a short leg given to us, so it's got to be across from the 30. You want the perimeter, you want the area, so you got to go through and find me the other 2 sides. Okay? So just like we start off here today doing, go find me the other 2 sides. We need to know the long, we need to know the hypotenuse. The hypotenuse there, we know is doubled. Okay, you got both short leg. Double that out, give me the hypotenuse. Short leg is 5, the hypotenuse is 10. Short leg is 5, the long leg is 5 root 3, correct. And we've got the perimeter now, we can calculate the area. So let's go do either one, doesn't matter, because we can find both of them at the same time. Area, we did that yesterday, we restarted review area. Area of a triangle, bless you, is 1/2 base times height. Again, I've just been trying to emphasize to you throughout the school year, the base and height have to be perpendicular to one another. What 2 sides up there are perpendicular to one another? I've got 3, which are my 2 perpendiculars. 5 and, yep, 5 root 3. So as we review this again, you're multiplying 5 times 5 root 3. 5 times 5 root 3 is 5 times 5. 25 root 3. Now, can we take half of 25 nicely? No, but we don't change it to a decimal, do we, Sam? We leave it as a fraction. Sam loves that. It looks ugly, but so do you in the morning. All right, so 25 root 3 over 2. Do we have units, Sam? What's that, Sam? We have units, right? Feet squared. Now that's my area. We got the perimeter still defined. Walk it around. We have like terms to combine. We got the 5 and 10 that will combine to 15. The 5 root 3 will not. Perimeter is 1 unit. And that's it. That's about as ugly as those will get. Okay, as we kind of come back around and re-emphasize perimeter and area. All right, let's look at another one here. Don't drop that. What do we remember about equilateral triangles? Equilateral triangles do what for me? What are all the same? The sides are all, in this case, what? 8s. Yep. All the same. Equilaterals, all the same. Now, let's keep going in with that equilaterals. What does equilaterals also imply? All the angles are the same, and more specifically, they are all. Now, let's keep going here. The next sentence says, hey, WY is the perpendicular bisector of XZ. I don't see a Y up there. So when we say WY is the perpendicular bisector, it goes straight down. Correct. So WY comes straight down in here to be created. And it's cutting that right in half, XZ. So it's perpendicular. It bisects it. And that's where Y is being created right there. Don't overthink that. It goes right down the middle. And what happens when that bisects it? It bisects that bottom 8. So what happens to that 8? It becomes 4 and 4. And what also happens up at the top there? Don't overthink what a bisecting does. Correct. And now it gets me a 30, 60, 90 triangle. And that's what we've been learning about today. It says find me the length of WY. So we want to know what the length of WY is right here. I'm going to call that question mark. That's a little messy for myself, so I'm just going to pull that triangle off to the side. Essentially what that problem boils down to is this right here. That whole description boils down to that itty-bitty triangle right there. Thank you, Harmony. Boils down to that triangle right there of what we just described to. Oh, Myra, we're in the middle notes, okay? Boils down to that triangle right there, which that's kind of what we started off with today, wasn't it? What's that question mark then end up representing? Long leg, short leg, or the hypotenuse? And that's nice. We got the short leg, so 4, 8, and 4 root 3. Now, in this instance, when they call that the altitude is the height of that triangle. It's that perpendicular height straight down. That's just another way to say the height of that triangle when they say the altitude of that. Okay? So don't freak out when they say the altitude. It's just another way to say that perpendicular height of that triangle right there. Okay? All right. If we got a second here, we'll come back to number 12. I want to drop it down number 13 with you. 14. Let's do 14 real quick. And if we got time, we'll come back up to the other one. Let's do 14 here, one of the what we call is a composite figure. Just smashing two of those triangles together. All right, it's a 30-60 in a combination with a 45. All right, let's use our skills here. Just like we did yesterday with these composites, with two 45s, now we have a 30-60 together. We got a shared side. Let's call that Y. Start off with that 7. That 7, we got to carry that on over to find that shared side. If it is helpful for you, I'll redraw that triangle there. Looks ugly, but it is what it is. That's not a Y there. Should be a 7 right there. Should be a 7 here, and this is my Y. So, get out of that mindset of a 30-60 for a quick minute. Go back to yesterday. 45, 45, 90. What is that Y representing that we need to find first? Is it the leg or the hypotenuse? What? The hypotenuse, right? We got the 7, don't need the other 7. But we got the 7, we need the hypotenuse. So it's the leg, it's times root 2. So that shared side that we need is across from the right angle, which is 7 root 2. So we got a 7 root 2 to start off with. Now that we got that 7 root 2, if it's helpful for you, redraw that triangle. That 30, 60, 90 triangle. Now, that 7 root 2 that we have, we want to find that x. Go back to exactly what we started off with doing all through today. Go back to 30, 60s now. What does that 7 root 2 represent that we have? Is that the short leg, the long leg, or the hypotenuse? What's the 7 root 2 represent? It's the short leg. And what does the x represent? The what? It's the hypotenuse. It's across from the 90. So to go to the hypotenuse, we need to double it out. It says x times 2x. 7 root 2 times 2. So what is 2 times 7 root 2? 2 times 7 is 14 root 2. So we're going to start intermixing all our problems together now. Okay. All right, let's go up one more. Let's go back to 12. We got the time for it. What shape we got there? There's a trapezoid. Now with that trapezoid, okay, who really cares? Let's cut it up. Let's find A and B. So on A and B there, we got ourselves a trapezoid, and inside that trapezoid is hiding a rectangle, and not just any old triangle, but now as we cut that up to make a right angle here, we got a 60 and now a 30. So we have ourselves a 30, 60, 90. Now we've done some of these problems before, but we had to use Pythagorean theorems with these. But now we've got another tool here where we can use a 30-60, or I can give you another trapezoid like this, where I can give it a special one where it's 45 as well. So you've got Pythagorean theorem, 30-60s, and 45s you can use with all these. All right, what do we have here? We've got this 2 root 3. We slide that over. This is also a length of 2 root 3. And in that 30, 60, 90 triangle right here, we're pretty solid then, where that 2 root 3 represents 60. That's the, long leg? And because that's the 2 root 3, that's my long leg. Walk back to your reference triangle. What does that long leg represent? It's X root 3. That's nice. It's a root 3. You should be able to tell me quickly the short leg is. The short leg is 2. 2 root 3 equals x root 3. Divides quickly. Boom, boom. X is 2. Now, where does that 2 go? It goes across from the 30, which is my short leg, which is going to be right there. Now that gets me the hypotenuse, which represents variable A right there. Now I got to finish this thing off to get variable B. Now that 5 represents this entire base up here for the trapezoid, which is all 5. This 2 is only the triangle portion. So what's this remaining portion? So B is a length of 3. 2 plus 3 gives me that 5. And there's your 30-60s. One more time, as I tried to emphasize to you yesterday, you better make sure you're doing the practice tonight. Don't come home tomorrow without doing the 30-60s practice. And on tonight's assignment, it's obviously a bunch of 30, 60, 90s. I also have a bunch of 45s on there as well, intermixed with that. So today, you got yourself, again, that 4th hour where they give you some time, or another class that you have that some downtime on. Get this out, get that homework going. Tonight, again, as well, don't stay up until 10:30, 11 o'clock to get homework, because you know good. Use the stage, use time during school, work on it. Forward, 10 o'clock. Or 9:30. When spring sports and now are obviously starting, so that's where you find be better kind of balancing the work time during the school day. Turn off that phone. Give me what time during school. All right. Got about a weird 5 minutes there. Tomorrow we'll come in, go over any questions.